In our last video, we defined the transpose of a matrix. We said that if we have a matrix A that's m by n, and we can write it as A sub ij with lowercase a, then the transpose is an n by m matrix where we switch I and j. So for example, if we had the matrix 1, 2, 3, 4, 5, 6, then the transpose is flipping this matrix along this diagonal. So this is a 3 by 2 matrix. We're going to have a 2 by 3 matrix. That looks like this. A symmetric matrix is a matrix that when you take the transpose, you get the original matrix back. So let's let A be a square matrix, so it's an n by n matrix. We call this a square matrix, which just means we have the same number of rows and the same number of columns. So the number of rows is equal to the number of columns. A symmetric matrix, so A is symmetric if A transpose is equal to A. Let's circle this and put it in a different color. So let's look at an example. Let's say A is the matrix 2, 3, 1, 1. This is a 2 by 2 matrix. This matrix is symmetric. If I take the transpose of this matrix, it leaves the diagonal fixed, but it flips these two, and I'll just get the same matrix. So A transpose is 2, 1, 1, 3. So A is symmetric. However, if I take the matrix B, which is, let's say it's 1, 2, 3, 1, this matrix is not symmetric because the transpose of this matrix is 1, 3, 2, 1. Even though the diagonal has the same number here and here, when I take the transpose, I don't get the same matrix because I have a 3 here and not a 2. So this matrix B is not symmetric. Let's look at another example, a bigger example of a symmetric matrix. Now, why does it have to be a square matrix? Well, obviously, if it's not a square matrix, let's say it's a 3 by 5 matrix, then when you take the transpose, it'll be 5 by 3, and two matrices can't be equal if they don't have the same size, so it has to be square. Let's say we have the matrix C equal to 1, 0, 0, 2, a 1 and a 9 here, a 1 and a 9, and a 3 here. This is a 3 by 3 matrix that is symmetric. Take the transpose of this matrix. Remember, all you have to do is flip it along this diagonal. You see that these two flip, and these flip. C transpose is equal to C. So it is a symmetric matrix. Let's find this right here. It says 2 times A minus B plus A times B transpose, where A and B are these 2 by 2 matrices. So I just want to combine these matrices here. And how we're going to do this is we're just going to follow order of operations, just like we do normally with real numbers. So I'm going to take A and multiply it by 2 using scalar multiplication. And then I'm going to subtract B from this 2 times A. And then I'm going to add to it, well, I'm going to multiply A times B, then take the transpose of that matrix and add it to 2A minus B. So let's figure out all these little pieces. Let's start with 2A. 2 times A is 2 times 3, 2, 1, 4, which if you remember from scalar multiplication, this is 6, 4, 2, 8. So I send in that 2 to every single thing inside the matrix. Now let's find 2A minus B. Well, 2A is 6, 4, 2, 8. Subtract B, which is 1, 0, 2, 7. And we get 5, 4, 0, 1. 6 minus 1 is 5, 5 minus 0 is 4, 2 and 2 make 0, and then 8 and 7 make 1. Okay, so we've figured out this piece right here. Let's find A times B and then take the transpose of that. Okay, so first A times B, that is equal to 3, 2, 1, 4 times the matrix 1, 0, 2, 7. Okay. So maybe pause the video and see if you can multiply these matrices. We get row 1 times column 1, so 3 plus 4, that's 7. Oh, sorry, no, not. Yeah, 3, that's 7, sorry. And then row 1 times column 2 will be 14. Row 2 times column 1 is 1 plus 8, that makes it 9. And then row 1 times column 2 is 28. Now we want to take the transpose of this. So we figured out what was in the parentheses. Taking the transpose would just be 7, 9, 14, and 28. So our last step is to take 2A minus B, which is right here, and we're going to add to it. Recall that this is what we're trying to find. We're going to add this A times B transpose. Okay, so let's put this in black. 2A minus B plus A times B transpose is 5, 4, 0, 1 plus 7, 9, 14, 28. And we're left with 12, 13, 14, 29.